Professor,
Yes, go ahead.
I just have a quick question. I noticed that you create Zoom meeting from Monday and Wednesday for lab at 12 p.m.
Mm-hmm.
The same also Tuesday and Thursday at 12. So
Yep.
always our meeting will be from 12.
Yep.
So how about the one we met at 4? There's no meeting at 4?
That's lecture.
Oh, okay.
Yeah. Oh, yeah. So I'll have to send out a separate Zoom for that. Because I think the meeting I set up, the Zoom meeting I set up for yesterday's lecture was just a one-time only. So I'll be setting up another one today.
Professor, I have a question too.
Yep. Mm-hmm.
Where can we access the recordings for yesterday?
They'll be on YouTube. I'll be posting them this weekend. I have to edit them first.
Thank you, Professor.
And get them uploaded. So yeah, so there'll be a link on the Canvas page to them, and there's also a link to the YouTube page where you can find them. So you should be able to find them in both places.
Thank you.
Yeah.
So we will have meeting every day morning and at 12 and 4.
Yeah, it's crazy. This
No, it's okay, but just I want to make sure to like adjust my time.
Yeah. The summer session is extremely intense because basically we have to take what normally spend about 18 weeks working on and squish it into 8 weeks.
Okay.
So yeah, so it's a lot of all at once. So have you taken a summer class before?
No. That's why.
Yeah. It's a lot of work all at the same time. So yeah, pace yourself. You don't want to get burned out. Any other questions?
Hi, to clarify, we are attending 2 of these types of sessions, one with the lecture and one with the lab. Yeah.
Right. Yeah, so tomorrow there'll be a lab at this time.
Okay.
And Thursday there'll be another recitation like this.
Oh, I mean, like, I'm in the other lab, and so, like...
Oh, so you should be going to the recitation at 6 tonight.
So, should I still attend this one, then?
You can hang out. Yeah, that's... No learning. No, yeah, of course you can. But, I mean, you're also scheduled for 6:30, so... Which either one would be fun.
Oh, okay. Good to know. Thank you.
Yeah.
Another question for lab, is there any bucket that we have to take it from the school?
I couldn't hear that one.
I said, I don't know, for lab experiment, do we have to pay bucket to do the experiment or no?
Do you have to do what for the experiment?
Like, my friend, she took chemistry 220 and she told me I have to pay the bucket from school to like material to do the experiment at home.
No. There's a lab manual that's linked on the Canvas page. Lab manual is for experiments that we would have been doing in lab. But the instructions for each lab will be posted on Canvas. So the instructions for the first 2 labs are posted on Canvas. You don't have to buy them.
Okay.
Professor, one question. For the lab tomorrow, we have to finish the pre-lab, right?
If there's a pre-lab in there, yes. I can't remember if there's a pre-lab in there or not.
I thought there's one on the lab manual, but not on the online lab.
No, if it's in the lab manual, that's different.
Okay.
Pay attention to the instructions that are. You can probably hear that in the background. Enough, you guys. Oh yeah, if they're posted on the individual lab instructions on Canvas, if there's a pre-lab in there, do that. But if it's on the lab manual with all the instructions in it, don't bother with those unless it's referenced in the lab instructions. Oh, Will, you. Yeah, they're worked up today. So anything else? So the way we were going to do this is I have all of the questions here in PowerPoint. I figured I would just ask which ones you want to sort of review, and we'll go over them together. I'm not going to do all of them because it's, you have to do some of this work yourself. But if you're like, some of it is stuff obviously we haven't covered yet because we've only had one lecture. So if there aren't any other questions about the class in general, are there? No? Okay. So is there any particular question you guys wanted to start with?
Number C, the 0.0124.
Okay. I'm going to just get this thing started then. Okay. So yeah, we haven't really gone over scientific notation. And so basically scientific notation just gives you the number of significant digits that are required, followed by the power of 10. So scientific notation always has to start with a number more than 1 and less than 10. So it's going to be, something like, oops, I need my pen here. And pen, there we go. So you need something like, 1.24 times 10 to the 7th. So that would mean we have 3 significant digits, 1, 2, and 4, and then followed by multiplying the whole thing by this power of 10. So for this first one, could someone tell me how this first one would go? First of all, how many significant digits are there?
4.
Okay, 4. Anybody else?
5.
5. Anybody else? Do I hear 6?
6.
There you go. So it's either 4, 5, or 6, right? So the way to tell is zeros that are before the decimal place. So if I have, for instance, if I have that number and then with a decimal, how many significant digits do I have here?
4. 3.
If there's a decimal there, the answer is 4. If there's no decimal there, how many?
3.
3, that's right. The decimal tells you that everything before the decimal is significant, okay? And it's odd to see, but that is actually a number. If you have, 1240 followed by a dot, that means that whoever was counting, remember, this is a count of something. We don't know what it is, grams or trees or cars or whatever it is. But if there's a decimal after there, what that means is that it's not 1239 and it's not 1241. It means it's significant to this number right there. So all those numbers are significant. On the other hand, if you see 1240 like this, all that means is that it's not 1230 and it's not 1250. It's somewhere, it's between that, and it's closest to 1240. So it's really only the first 3 numbers that are significant. Now, that is different. Oops, here we go. That is different when we have numbers past the decimal place, like this one. Oops, let me go back. Here's my pen. There we go. So with this number, we have zeros past the decimal place. And what this means is that any of these trailing zeros after are significant, or they wouldn't be there. So in other words, 0.1 means that it's not 0.09 and it's not 0.11. But, or actually, it's not 0 and it's not 0.2. That's what that means. Never mind that. So this is only good to that one significant digit. But if I have 0.10, that means it's not 0.09 and it's not 0.11. So both these numbers are significant. So any zeros that are trailing after the decimal place are significant. So if that's the case, who can tell me what this number is, that first number? What's that first number? If all those digits are significant, how would we express that? The trailing zeros are significant. That means there's six sig figs. So what number is? How would we put that in scientific notation? So I want to take a stab at it. Nobody wants to try? That's the whole point here. We're doing a workshop session. I'm just not going to sit here and dispense wisdom from on high. You guys got to.
How about 5.80900 times 10 to the negative fifth?
0, okay, times 10 to the, let's see. So we go 1, 2, 1, 2, 3, 4, 5. That's right. Yeah, that's right. So that'd be the correct answer. And the reason we, like I said, the reason we include these is because someone was able to measure that precisely. And when we're dealing in a lab situation, precision is extremely important. And we'll go over a little bit later why precision and accuracy aren't necessarily the same thing. Precision could mean that you're getting the same very, very precise answer, which is wrong every time. And so that's not so great. But you'd like to have both precision and accuracy. But this is a measure of precision. This tells you how much error there was in getting that particular measurement. So anyone want to do the second one then? First of all, how many significant digits are in the second one?
6.
I heard 6, okay.
So I have a question about the recitations. So are we just supposed to be doing each problem that like are on these slides, and then we'll like turn it in on Canvas, or?
Yeah, well, you should have like this either on your screen or printed out, and then you can just write out the answers like on a. If you printed it out, you can just put the answers right on the paper, take it that and submit it. And if you can't print it out, just write it on any kind of paper you want. Just write out the answers to the.
Okay.
Put down your name, your section, the date, and just put the answers down.
Okay.
At that, and it's due a week from today, so there's no huge hurry. So the first one, there was six significant digits. How many in the second one?
Is it 4?
4.
4. 12. What? Oh, 4?
Yeah.
Yeah, it's 4. Right. So those trailing zeros before the decimal point and the decimal point there. If there was a decimal point there, they'd all be significant, but there isn't. So any trailing zeros they're not significant then. So yes, so there's 4. So how would we write that in scientific notation? So first of all, we know that it's 3.809. Those are our 4 significant numbers, right?
Mm-hmm.
So times 10 to the what?
To the 6th?
4.
So remember, every time we move, so it's what, 3.80900. So every time you move 1 to the right, add its 10 to the 1, whoop, 2, 3, 4, 5, 6, 7. Whoops. 10 to the 1, 2, 3, 4, 5, 6. Sorry, 10 to the 6th. Yeah. You can always double check because 10 to the 6th should be a million. And if you look at that, yeah, that's 3,809,000. So a million should be 10 to the 6th. 1,000 should be 10 to the 3rd. Billion should be 10 to the 9th. And trillion should be 10 to the 12th. This is a little reminder. Okay, yeah, so the answer is this, right here. Those are our 4 significant digits, and that's the what you have to multiply it by. All right, now let's go to the third one. That was actually the original question. Raj, can you take him in the living room? Thanks. All right, so the third one, there was a question about that. So first question, how many significant digits? For this third one here. How many significant digits there?
4.
Okay.
3.
3.
3.
You're 5. Do I hear 2? Really, it's either going to be 3 or 4, right? It's one of those two. Just obviously, this first 0 is not significant.
Right.
The second 0 isn't significant either. Because basically all this second, so this 0 is not significant because basically it's a placeholder. It's telling us what to multiply by. And so is this one. That's not significant either. Basically, it's just a placeholder to tell us what we have to multiply these significant numbers by. That's all it is. So it's not the only thing it's telling us is what power of 10 to use. So it's not really involved in the precision of the measurement. It's just telling us what power of 10 to use. So we take, so how much, so if we're multiplying this by 10 to the minus 9, how many places do we have to move the decimal before we get to the first significant digit? 1, 2, before we get to this. So what did we change this minus 9 by? What did we change it to?
By 2.
11.
Minus 11, right, because every time we move the arrow to the right, it's something smaller. Every time we're moving the arrow to the left, it's something bigger. And so since we moved it 2 to the right, it means 10 to the minus 2. We've made it smaller. So when we multiply 10 to the minus 2 by 10 to the minus 9, we get 10 to the minus 11. That's right. Very good. Let's just quickly finish up and do the last one. Oops. There we go. So this last one, how many significant digits there?
3.
Mm-hmm. All right, I heard 3. Anybody else want to take a stab at it?
3.
3, okay.
5.
5. What about 4? What about 12? I heard, well, no. I just misheard that. So it's 3 or 5. Anyone want to go for 4 or 2 or none? It's at least 3, right? So it's got to be at least 3 and it can't be more than 5. So which one is it? Is it 3 or 5?
3.
3.
3. Okay. Who said 5?
Me.
You're right. Good for you. Yeah, there's 5 because there's a reason why those trailing zeros are there. The only reason to put them there is because someone was able to measure that so that it's not 202.01 and it's not 201.99. So it's that accurate. Well, not accurate. It's that precise. Okay, meaning all of these digits are significant. So that's why trailing zeros, remember, trailing zeros after the decimal are only there because you were able to measure that accurately. So but if this was 0.00202, these zeros are not significant. They're just placeholders for the power of 10. If they're after a number, they're not placeholders for the power of 10. They're a measure of how precise that number is. So there's 5 significant digits. So we would write down 2.0200 times 10 to the what?
5.
5? That would give us 1, 2, 3, 4, 5. That would be 2,000. That would give us this number. But remember, we've only got 202. So that can't be. We want to get back to 202.
3.
To the second?
To the second. Because we're only moving this decimal 2 places. We're going 1, 2, and we're moving it to the left. And so it's a bigger number, and so it's positive. So 10 to the second. So finally, it would be 2.0200 times 10 to the second. Okay? So whenever you see a question on a test or something like that, where you're asked for proper scientific notation, you're going to have the number has to be between 1 and 10, followed by 10 to the whatever it is. So you have to have the right number of significant digits and the right power of 10 to get full points. But I want you to know that when I grade exams, I grade to see if you know how to do the question. If you make a dumb mistake, and let's say, I also want you to show all your work. So showing all your work is essential. So show all your calculations. And so if you go through all your calculations and then you sort of, just make a brain fart and, have 2.02200 times 10 to the third, you're not going to lose all the points. You're still going to get 80% of the points because you did all the calculations correctly. You just, made a dumb mistake, and I make them all the time. And so really what I'm testing you is to see, do you know how to do this? And if you make a dumb mistake, that doesn't mean you don't know how to do this, it just means you made a dumb mistake. So it's no biggie. So on any exam, show all of your work. Don't just give an answer, because if you give an answer and it's wrong, I can't give you any points, and that stinks. So show all of your work, give the answer, and if you just make one dumb error, it's not a big deal, okay? All right, so what's the next one people want to do?
Go to question 2.
Just the next one, huh? Okay, why don't we do the third one, because that's probably the most confusing one.
Oh.
Does that sound good?
Yeah.
Do the third one?
Mm-hmm.
Right, so when you're doing these sort of questions, there's a difference with significant digits between adding and multiplying. Multiplying is pretty straightforward. It's very simple. If you're multiplying 2 numbers together, the final answer is the smaller number of significant digits. So if I have 10 times 223.01, this has how many significant digits there?
5.
5. Yep, that has 5. How many does this have?
1.
One, just one. So when you multiply those two numbers together, your answer is expressed with the lesser of the two significant digits. So you would give only one significant digit here. So the answer would be 2,000. Which seems weird, right? I mean, like, that doesn't make any sense. But when you think about it, when you multiply, if you only have one significant digit, all that's saying is that it's closest to the, it's not 1,000, it's not 3,000. It's the, whatever's the closest 1,000. And that's going to be your answer. So basically, you're sort of wasting a very precise number by multiplying it by a very imprecise number. So multiplying, pretty straightforward. Just whoever is the smaller number is sig figs, that's it. But when you're adding, it's different. And so when you have something like this, you want to do the addition first and then do the multiplication, okay? So let's erase this stuff and get to my pen again. All right, so let's do the addition first. So it's 61.2 plus 88.5. Now, when you add them, what you would do is just put them like this, just like back in school, like in grade 2 or something, and you just add them together. So what's the answer here? So hopefully people brought their calculators.
149.7.
Right. So how many of these numbers are significant?
4.
4.
4. All,
3. 4.
no, 4. All of them are significant. So you've taken two numbers with three significant digits, added them together, and now you have 4. So basically what you look at is where this would come into play is how many significant digits are beyond the decimal place. So if I was adding 61.001 plus 88.5, basically these two numbers no longer are significant because I don't have any numbers here.
Mm-hmm.
And so I would just, those would be gone and I would end up with 148.5. And that would be it. So here I'd have 5 significant, this would have 5 significant digits. This would have 3. When I added them together, they'd have 4. But you have to watch for beyond the decimal place. This is where it's important when you're adding numbers together. So basically it's after the decimal is cut off to whoever has the fewest number of significant digits after the decimal. If one has 3 significant digits and the other has 2, then you only have 2 significant digits past the decimal place. If one has 7 and the other has 3, you only have 3 significant digits past the decimal. So here, now this becomes 1.78 times 10 to the 17th divided by 149.7. So now we just do straight up division using the smaller number of significant digits. So what will we get if we divide one? So we can change this to 1,780 times 10 to the, what would that be? So I'm changing 1.78 times 10 to the 17 to 1780 times 10 to the, what's this number? How many places have I moved the decimal to the right?
13.
Yes, it is 13. So I've moved the decimal place how many?
4 times.
Let's see.
Ow.
2, 3. Actually, I've moved it 3 times.
So
Oh, okay.
14. Yeah. So let me erase that. So now I've got 10 to the 14 divided by 149.7. So what number do I get? So 1780 divided by 149.7 gives me what?
$11.89.
All right, some of this here. Right, so my answer is 11.89 times 10 to the what? 14, right? That hasn't changed. So I have two problems here. One, I've got a number bigger than 10. I can't have that in scientific notation. I won't be having it. So remember, we need a number between 1 and 10. So what are we going to change this 11.89 to?
1.189.
Yeah, 1.189 times 10 to the what? Now I
15.
decimal place 1 to the
15.
15, right. So I've made, if I make this number smaller, I've got to make this number bigger, right? So if I make this number 10 less, 10 times less, I got to make this number 10 times more. So they balance out. Yeah, so this is my answer, 1.189 times 10 to the 15th. Is that right?
Should be.
How many significant digits should I have? Remember, when I'm multiplying two things or dividing two things, whichever has the smallest number
Oh, you should have
of digits, that's the
3.
one I have to use.
You should have 3.
So I should have 3, that's right. I should only have 3 significant digits. And now I've got 4. So what do I do with this number?
You round.
I do, I round it. Exactly. So what do I round it to?
1.19.
1.19, that is correct. Yeah, so this 9 here is bigger than 5. It's 5 or bigger. And so when I round, it makes the number next to it go up 1. So the answer would be 1.19 times 10 to the 15 is my final answer. Yeah, so you have to have the right power of 10 and the right number of significant digits and a number between 1 and 10. That's what scientific notation is. Yes, question.
If I left my answer just 1.189, I need to round, or it's fine if I leave my answer, if I stop my answer until this step, like 1.189?
That's not correct.
Okay.
Yeah, I mean, you would, so if you went through, let's say if it was like a long question and all the way through it and then left it here, I mean, you would get most of the points, but it wouldn't be completely correct.
Okay.
Yeah, so you would lose some, but you wouldn't lose all, because obviously you did the calculations right to get that far. You just didn't use the right number of significant digits. So you'd still get, 70 to 80% of the total. And I would just write, and you will get tired of seeing this on your, I would just write sig figs with a big exclamation point. Because, yeah, significant digits are really important in doing chemistry or any kind of science, because it shows the kind of precision you can make. And you can't express, like when you're writing a scientific paper or something, if you're writing up, well, even if you're writing your lab reports, you can't claim more precision than you can actually get. If the piece of lab equipment you're given only measures volume to, like, let's say it only measures volume to plus or minus 0.1 milliliters. And we'll talk more about the metric system today, probably. If that's the maximum precision you can get, then you tell me you've measured a volume to 21.02 mils. That's incorrect. There's no way you could have measured it that accurate. It's impossible. So it would so you would write 21.0. That is the correct volume. because you cannot measure it that precisely, given the particular instrument you had to measure it with. There are other instruments that can measure things that accurately, but if you don't have access to one, then you can't tell me that that was the actual volume. And that's really important. Okay, so it's any other, next question?
Can you do the next one?
Yeah, we haven't gotten into what molar mass means yet, right? That's kind of important. So why do we do this one? Did anyone remember what the mass of a mole is? If I have a mole, oops, let me go back. If I have a mole of oxygen atoms, which I wouldn't, but if I had a mole of oxygen atoms, how much would that mole of oxygen atoms, what would be the mass of it? How would you figure it out? You need a periodic table. Oh, what happened? Oh.
Gonna be 8.
8 what? Remember, when you're giving a measurement, you need two things. You need an amount, and what else do you need?
A unit.
You need a unit. So 8 is not an answer. If I had a mole of, just keep your door closed. So if you have a mole of something, what do you need? Actually, where would you go to figure out this this bit of information? There's a certain place you'd need to go to figure it out.
Periodic table.
Yes, sir. You need the good old periodic table. So why don't we do that? I will. See if I can share. I want to share another. Where are we? New share. Let's go to the screen. So could everyone see the screen now?
Yeah.
Okay. So let's go to here and get. Oh, damn it. New tab. There we go. So there's this. It's here. Where is it? Ah. Oh, I thought I'd saved it. Anyway, it's called this. There's a great site for the periodic table. Periodic table. Yeah, here it is. So it's just ptable.com. I should have put a link in the. I'll put a link to it in the Canvas shell. But it's a great spot. Because what it does is basically here's the table, and it's fully interactive. So if you put your mouse over whatever element you're looking for, it gives you basically all the information you want on it. So let's go to oxygen. So I go to oxygen. If I click on it, it gives me all the information I'm looking for on oxygen. Taking a minute. All right, so actually it goes right to the Wikipedia page on oxygen. So all this stuff is here. But what we're looking for is right there. So over here is what we're looking for. So I've got oxygen. So the number 8, what number is that? The number 8 up in the top left-hand corner. What number is that?
16.
No, the number 8. When it's so.
Oh, Oxygen.
And it's got 8, and then below it, it's got 15.999. What number is 8?
The atomic number.
The atomic number, exactly. And what does the atomic number mean? There's a very specific meaning.
Proton.
Like the protons,
Yes, exactly. It's the number of protons in the nucleus, not the number of electrons.
Mhm.
Number of protons in the nucleus determines what element it is. The number of electrons is irrelevant. That tells you what the charge is, but the number of protons in the nucleus tells you what element it is. So if there's 8 protons in the nucleus, it's oxygen, and it doesn't matter how many neutrons there are. If 7 protons in the nucleus, it's nitrogen, and it doesn't matter how many neutrons there are. So the number in the top left-hand corner is, the atomic number. What's the 15.999? What's that?
Atomic weight.
The atomic weight or the atomic mass. We want to say mass in chemistry, right? It's the atomic mass. And what's that?
Protons and electrons combined.
Nope. You're close, but no.
like protons and neutrons combined.
Yes, that would be the atomic mass of one atom, would be the number of protons and neutrons together. But you notice here that it's 15.999. Why is that? It's not 16.000. How come it's 15.999?
Units.
It is a unit. What unit is it?
Moles.
No. It is something per mole. It's a unit per mole.
Grams.
Grams over
Grams per mole.
Grams. Yes, it's grams per mole. So why is it less than 16? It should be precisely 16, right? There's 6 protons and there's 6 neutrons. How come it's less than 16? That doesn't make any sense. And look at nitrogen, it's more than 14, and carbon's more than 12. What's going on here? Anyone know why? We haven't learned it yet, but I mean, maybe you'd remember it from high school. There's different forms of the same atom. Anyone remember what the different forms are called?
isotope.
Isotope. There you go. Exactly. Yeah, and an isotope has the same number of protons because it has to. It would be a different element if it didn't. But it is a different number of what?
Electrons.
Nope, not electrons. That determines the charge.
Neutrons.
The same number of protons
The same number of neutrons.
of something that determines mass. Remember, electrons hardly have any mass at all. But protons have mass, and something else does too.
Neutron.
Neutrons, that's right. An isotope is the same element with a different number of neutrons. And so since it's slightly less than 16, tells me that there are a very small number of oxygen atoms that have a mass of 15. So they would have 8 protons and only 7 neutrons. But since it's 15.999, it tells me there aren't very many of those. And so this is the average atomic mass because it takes all of the different isotopes and it gives me the average of all of them mixed together. So this 15.999 tells me that like 99.999% of oxygen is 16, and that tiny percentage is 15. And that's pretty much right. There's almost all oxygen is 16. There's very little 15. I think there's a tiny amount of 17. It's like super, super small. Okay, so that's the average atomic mass in first unit atomic mass units, which doesn't really mean anything to us. But what's more important, grams per mole. Meaning if we have a whole mole of these, it would weigh 15.999 grams. So let's go back. So we want the molar mass of calcium phosphate. So Ca3PO4 2. What is this second 2? What does that 2 mean? So Ca3, we sort of can put our heads around that. So there must be 3 atoms of calcium, right? But what's that 2? What is that for? There's a brackets and then 2. What does the 2 mean?
2 times the
Like you multiply
Multiply what by 2 though?
2 times PO4, like those values.
Like everything.
But like it would be like P2 and then 08.
That's right. But we don't write P2O8 because that is not
Right.
ion. This, we'll learn a little bit later, is an ionic compound which has calcium plus 2 is one of the ions, and PO4 minus 3 is the other one. And PO4 is, oh man, what the hell's going on? Okay, Jerome. So PO4 is what we call a polyatomic ion. They're all together. They're linked together by covalent bonds. They're stuck together. And it's 1 phosphate and 4 oxygens. And you can't just add more phosphates and oxygens. That is the working unit, PO4. And there's 2 of them. So, Jerome, here, come on up, buddy. Try and chill. So there's 2 of those, and that's called phosphate. It's a phosphate ion, and there's 2 of them. So if we want to figure out the molar mass of this whole thing, we have to add all the atoms together. So how many calcium atoms are we going to have?
3 times.
We're going to have 3, right? Yep, 3 calciums. Okay, how many phosphates are we going to have?
2.
What was that?
2 times.
2. We're going to have 2 phosphates. And how many oxygens?
8.
8, that's right. So we already figured out that our average atomic mass of oxygen is 15.999 grams per mole. Let's go back to our ptable.com and find out. Now, where am I going to find phosphate? Phosphorus. P is phosphorus. PO4 is phosphate. We'll learn about that. Where's phosphorus?
15.
15. Man, you're quick. So, what is the average atomic mass of phosphorus?
30.974.
There you go. 30.974. And there's 2 of those. So 30.974. And then calcium. Where are we going to find calcium?
40.078.
20.
20 is element number 20. Is in group 2. Since it's in group 2, it likes to have a charge of +2. And it's always +2, actually, when it's an ion. And we can see that its atomic number is 20, meaning it has 20.
2.
And it has an average atomic mass of 40.08. 40.08. Okay. Now, I'm going to go.
Professor, I have a question.
Sure.
On the exam, I have my own periodic table, but the numbers are a little different.
Hopefully it has the same, and hopefully it has the same masses. That's,
It's just that digit is different. So would you like us to use the online or the one that I reference for?
how many, you've only got 2 digits past the decimal?
Oh no, like for the phosphorus, it was 30.973, and then the calcium,
Yeah, that's fine. I mean, I like to use the ptable.com just because it's quick. I know where it is, and it's got information like densities. Like the lab we're going to be doing tomorrow is like on densities and using density to identify different things. Guys, so the densities of different metals. It's got the vapor pressures and the atomic masses numbers, and it's got pretty much everything you need in there. If you just have a sheet with all of them on there, yeah, that's fine. Just use that, because if you're off by like 3/1000ths of a gram, that's not a big deal. as long as you do your math right. That's the important thing. All right, so let's get a pen out. So this is the information we've gleaned so far. So we've got 3 moles of calcium atoms. We've got 2 moles of phosphorus atoms, and we've got 8 moles of oxygen. And we know our calcium is 40.078. Our phosphorus is 30.974, and our oxygen is 15.999. So what do we do from there?
We multiply
What do we multiply?
the 3 times 40.078,
Mhm.
the 2 times 30.574, and 8 times 15.999.
That's right. Now, I have a question for you. We just learned that when you multiply 2 numbers, you use you would use the smaller number of significant digits. So when I multiply 40 times 0.78 times 3, how many significant digits should I get?
Five.
Why is that?
Um,
6.
I heard 5, I heard 6. What about 1? I mean, 3's only got 1 significant digit, right?
mhm.
Should it be 1?
Yeah.
But the 3 multiple 4 is gonna be 12.
Wait a minute, 12? Where do I get 12 from?
No, I mean when you multiply 3 by 4,
Mm-hmm.
it's gonna be 12. So
Right.
the digit will extend, not.
So the answer is this 3 is different from the 3s we've been talking about before. That 3 is not a measurement. That 3 is an exact number. It's not 1, it's not 2, it's not 4. It's exactly 3 moles of calcium. There's exactly 3 atoms of calcium in there. That's a count. And a count is different from a measurement. So basically what that means is 3.0s to infinity, because it is exactly 3. So that is a bit of a trick there. So the smaller number of significant digits would be this one. So it would be 5. Okay, that's a bit of a tricky one there, but It's exactly 3. And when you have a count that's precise and it's not an estimate. So a measurement is basically you have the significant digits and then you include an estimate of the last significant digit. There is no estimate. It's precisely 3. So that's different. So that is an infinite number of significant digits. So we just take whatever this number is. Okay? So what is that number? 40.078 times 3.
120.234.
1.2. Oh, damn it. Okay.
Isn't it like 5 sig figs? So like 120.23.
Yeah.
You have to round it, right?
Yeah. So that last one goes. So next one.
61.948.
2. So 61.95. Oh,
48.
948. That's right. 5 significant digits. Yeah. And then 15.999 times 8. 127.992. Have these 3 numbers. This one is 2 digits past the decimal place. This one is 3, and this one is 3. So basically, we'll add them all together, but we'll only report 2 past the decimal place. Okay?
Wait, isn't the last one 128? Because 5 sig figs?
Yeah, 128.00. Right.
Yeah.
Yeah, so let's add them all together. So 120.23 plus 61.948 plus 128. So we get 310.178. Now remember, we can only have 2 digits past the decimal because of this first one. So what do we change this to?
5 sig figs.
So what do we change this number to?
310.18.
310.18.
Yeah. Now remember, that's a number. That's not the molar mass. Because a measurement in chemistry has to have a number and what's the second thing it has to have?
Units.
Units. So that's the other thing you get tired of seeing. I'm going to be writing sig figs on your papers all the time. And the other thing I'm going to be yelling is units.
Grams over mole.
Because this number is meaningless without a unit next to it. It doesn't tell me anything. It's just a number. Yeah, so I'd have to have grams per mole. That is the molar mass. So 310.18 grams per mole. Okay. Next. Oh, man. Come on. Kenny. Yeah. So this activity going on outside. So they're just, yeah, very interested. So next question. Who wants to suggest the next one? So dimensional analysis we haven't really talked about. We're going to do that today.
Of it.
So that's fairly straightforward. What about B, moles of water in a bottle that holds 500 grams? That's probably a good one to do. Or what do we need to figure out to do that problem?
The molar mass of water.
There you go. Molar mass of water. So who's got a periodic table? We know what oxygen is. We've already worked on that one. So our oxygen is, whoops. So our oxygen is, man, why can't I write it? my oxygen, damn it, not writing. There we go. So our oxygen is 15.999. Then someone want to look up hydrogen?
1.008.
Yep. So 1 times 15.999 and 2 times 1.008. So this, so what's my total?
18.02. Oh, sorry. 2.02.
18 point, what? Remember,
02.
I've got 4 significant digits here.
So it's 02.
I have 3 past the decimal. 18 point, these are all significant.
015.
There you go. Now what are my units?
Grams per mole.
Grams per mole. So when you're doing this sort of what we call dimensional analysis just means you're changing one unit to another unit, okay? So whenever you're doing this sort of problem, I always write down what information am I given straight away. So we're given 500 grams, 500 decimal grams of water. So how many significant digits are here?
3.
3, right. So I'm going to multiply, so dimensional analysis just basically means I'm going to multiply this by something that's going to give me moles of water at the end. Now I always tell students, never divide. Never ever divide. Always multiply. And the reason for always multiply, my pen went away for some reason. I start with the units, oh, damn it, go back. I start with units of grams, and I want to finish with units of moles. Meaning whatever I multiply by, I want to have grams on the bottom, because when I have grams in the numerator and grams in the denominator, they cancel. And I want to have moles in the numerator, because when my grams cancel out, I want to be left with moles. So moles will be on top, grams will be on the bottom. So what do I put here? What numbers do I put right there?
18.
I want to change grams of water to moles of water.
1 mole over.
Yep. So 1 mole of water over
18.015.
Yep, 18.015 grams. So that means my grams are on the top, grams are on the bottom, they cancel and go away, and I'm left with moles. So even though you're dividing to get the answer, don't set it up as a division, because that makes it too confusing. I don't know, when I divide units, I don't know where they're going. When I multiply by units, I can see clearly what's happening, because I see what units on the numerator, what units on the denominator. My units in the numerator are going to stay. My units in the denominator are going to cancel. So that's why I always multiply. That saves me from making that mistake. So 500 divided by 18.015. So my answer is 27.746 moles of water. So I have the right units. I need the right number of significant digits to get full credit. So how many significant digits should I have?
Is it 4?
4? Where do you get 4?
What, because hydrogen has 4, right?
Mm-hmm. But remember, I'm multiplying or dividing, which, I mean, dividing, multiplying, basically the same thing. I'm dividing 2 numbers how do I determine how many significant digits to use? So these are the numbers I'm multiplying. This one and this one.
3, right?
3. Yes. You use the smaller. Whoever has the least or the lesser number of significant digits, that's how many I use. This one has 3 because it's 500 decimal place. So it means all 3 digits are significant. This one has 5 significant, 2 before the decimal and 3 after. So I've got one with 3 and I've got one with 5. So my final answer should have 3. How do I, no, 3, because we're not adding them, we're multiplying. So whoever has the lesser number of significant digits, that's the one we use.
Okay.
So basically, what it means is basically we're limited, the precision of our answer is limited by the precision of one of those numbers. And so this number here limits the precision of our answer. We can't be more accurate than 500 grams. If it was 500.000 grams, that's super precise. Then we could say more precisely how many moles there are. But it only says 500 with a decimal. So we can't give more precision to our answer than that measurement has. So we have to reduce this to 3 significant digits. So how do I do that?
You round it to 27.8.
8, that's right. This is a 5, so we round up. So our final answer would be 27.8, and then our units are moles of water. So that would be the total complete answer. It's got the proper number, it's got the right calculated number. It's got the proper number of significant digits, and it's got units. So it's like the 3 things you're looking for. All right, cool.
So I have a question, Professor.
Yeah.
How come you didn't use, are we doing the significant number at the end when we round? So we keep everything the same, like when you multiply the oxygen and hydrogen, we kept the original numbers until.
That's an excellent point. Something you want to do when you're doing these sort of questions, carry all of the significant digits. When you're doing your calculations, carry as many significant digits as you want. If one number has 5 significant digits and the other one is 6, when you do your calculation, just write down all of them. Notice I wrote down like 6 here. I could have written down 7, 8. It doesn't matter. Carry all of them through. Do not, one mistake that a lot of students make is they round things too early. They take, like, a lot of these questions you're going to have to do 2, 3, 4, 5, 6 calculations before you get to the end. And so, students are always asking me, well, how many numbers should I have in my calculator? And I say, all of them. Use all of them. Doesn't matter. Use them all. Because you don't want to decrease the precision of your answer until you get to the end. So what students will do is that they will round things too quickly. So like 500, if they have to do a number of different calculations, they'll round everything to 3 before they get to the end, and then they'll find that their answer will be different from other people who carried all the significant digits. So carry them all. Carry as many as your calculator will hold until you get to the end, and then figure out where in my calculations am I limited in my precision. And when you do this one, you're limited by the amount of grams of water. That's your limiting precision. So my final answer has to be limited to that amount of precision. But don't round too early. That's a really common mistake. That's an excellent point that I forgot to mention. Yeah, people make that mistake all the time. Then, yeah, don't do it. because someone will get like 27.8, someone else may get 27.7, somebody else may get 27.6. And they did all their math right. They just, you know, they rounded something too early. All right. So who else has another question? We got some more time before we finish up. That took a while. Very pretty. So which question would people like to do next? Quiet.
Question number 5.
Number 5. Let's see what that one is. This one? Stop me when we get to it. Is that 5?
Yeah, what is the mass of aluminum?
Aluminum? Okay, cool. All right. So we have, so I always like to write down what information do we have. So my information is, give me the pen, please. There we go. So I got 4.85 meters long and 6.25 millimeters radius. Okay. And I got aluminum. So, couple things here. So we're dealing with volume. So I want my final answer has to have mass, but I first need to calculate a volume. So I need something that relates mass to volume. And what is that? What's something that relates mass to volume? So we're dealing with aluminum, and I want a mass to volume ratio. What is the mass to volume ratio for something?
Is it the density?
It's the density. Excellent. So we need to look up what's the density of aluminum. Can someone look that up? I think it's 2.7 grams per mil, but I can't remember.
It's 2.7.
Dang. So 2.70? We might as
I
well.
think it's just
This is a
2.
classic example of use all the significant digits you have. So if they give you 7, use them all. And then we'll figure out how many to report at the end. So is the density just 2.7?
Yeah, it's just 2.7.
Okay. 2.7. So remember, that's just the number. What units do we have?
We have the mass.
What's the mass in?
Grams per centimeter cube.
Grams per centimeter cube, which is also 1 mil. The same thing. So grams per centimeter cube. Actually, that'll help us for this one. So we have a mass or volume. So what we need to do is figure out what is the volume of this thing that's 4.85 meters long and has a radius of 6.25 millimeters. And we're going to use this formula. So our volume is pi times 6.25 millimeters squared times the length. Now I want to have the same units. I can't just be multiplying millimeters by meters. So can anyone tell me how many millimeters there are in 4.5 meters? Here I'm going to do another conversion. Now I'm going to multiply this by something that gives me millimeters at the end. So what do I want to multiply this by?
1,000 millimeter over 1 meter.
There you go. Yes, there's 1,000 millimeters and 1 meter. Now I cancel my meters, I'm left with millimeters. So I have 48500. 1, 2, oh, sorry. 4,850. Oops. 850. So I'm going to multiply this by 4,850 millimeters. So what is my final volume?
Can we multiply it with the pi as well?
Oh yeah, pi is part of it. Definitely. And here, again, you would use this, if your calculator gives you 16 significant digits for pi, use them. No sense rounding off pi to like 3.14. That doesn't help anybody. So, you know, if you're at a supercomputer and if you got pi to a billion digits, just go ahead and do the calculation with that, and we'll figure out how many significant digits at the end. So what's the calculator should hopefully has pi on it. Or if you're a nerd, you remember it's 3.1415927, right? Something like that. 6538978. Yeah, God, yeah, married an engineer. That's what's going to happen. So times 6.25 times 6.25 times 4850. So what's my final volume?
595,184.5457 millimeters.
595,184 times 6. Well, what's my units?
Millimeters?
Nope. It's volume, remember. I'm multiplying millimeters by millimeters by millimeters. So what's my final unit?
M3. M to the power of 3.
To the power of 3, yes. Cubic millimeters, because it's a volume. So an area would be square, right? Millimeters. Length would be millimeters. Area would be square millimeters. And volume would be cubic millimeters. So we have this number. And remember, like I said before, keep all those digits. You can have as many as you want because you haven't got your final answer yet. So I have 595,184.6 cubic millimeters. Problem is my density is in cubic centimeters. So, I'm going to have to convert cubic millimeters to cubic centimeters. So what I want to do is take this, multiply it by something to get me to cubic centimeters. Meaning I'm going to want to have cubic millimeters on the bottom, cubic millimeters on the bottom, and cubic centimeters on top. Now, what's the relationship between centimeters and millimeters?
10.
10. So there's 10 millimeters. So 10 millimeters equals 1 centimeter, right? Does everyone that sound good to everybody? 10 millimeters is equal to 1 centimeter. Does that sound right? Yes? No?
Yes.
Good. At least one person agrees. It is. Yeah, there's 10 millimeters in a centimeter. Now, where everybody makes a mistake, including myself, I've made this a number of times, is if there's 10 millimeters in 1 centimeter, how many cubic millimeters are there in a cubic centimeter? And so what people will do is they'll put down okay, there's 10 millimeters for every 1 centimeter. That's how I do my conversion. That's not right.
Is it 1,000?
What is the right conversion to use?
Do you cube the millimeter?
Yes, exactly. So what you would do, let me just get my eraser out. So what you would do is I would erase this third, I would erase that third. See, this is correct, 1 centimeter over 10 millimeters. But since we're cubing, we want to cube both. So I cube the top and I cube the bottom. And when I cube 1, I still get 1. But when I cube 10, what do I get?
1,000.
1,000, that's right. So this becomes, there's 1,000 cubic millimeters in 1 cubic centimeter, okay? And so then what does this 595,184.6, what does that get converted to? And then now I need to divide it by 1,000. Where do I move my decimal place to? Right now it's here. Where do I move my decimal place?
Three to the left.
Yes, 3 to the left. 1, 2, 3. So now I've got 595.1846 cubic centimeters. Let me erase some of this stuff so we can finally set up our final answer. All right. I have 595.1846 cubic centimeters. And I want to multiply that by something that spits out grams. So what am I going to put in here to get me grams? What am I going to put in the brackets to give me grams? Oops. I need to put something in here that will convert my cubic centimeters back to grams. What goes in there? The density, that's right, the density, because we're dealing with the density of aluminum. So so I need grams on the top, right? So I want to end with grams. So I put grams on the top, and I want to get rid of centimeters cubed. So I put centimeters cubed on the bottom. So what do I put in here? How many grams per centimeters cubed?
2.7.
2.7. That's just the density. That's right. So then I just take my 595.1846 times 2.7, and I get 1606.998 grams. So what do so obviously that's way too many significant digits, right? So what do I convert this to? How many significant digits should I be left with?
2.
2. So what would be my final answer?
1,600,000.
1 million? Like, this is
Oh,
the
sorry.
1606.998. Yeah, it's hard to make a decimal with that. So what's my final answer?
1600.
Yeah, exactly. 1600. But that's not my final answer because it's 1600 grams. I have to have a unit. If I don't have a number, if I have a number with no unit, it's not an answer. It's just a number.
1600
1600 grams.
grams.
Yeah, because we had 1606.99. So we have to round that to 2 significant digits. So then we only get 1600. Now, if we had 2.70, we'd have 3 significant digits. And it would be 1610. Uh-oh, someone just gave up.
Are we looking at the question to find the significant digit amount number?
Yeah, you look at the question, you see what number has the fewest number of significant digits that I've used in my calculations. And this number right here, the density that you looked up. So if you looked up, so what I would do if this was on a test, I would give you the density, and I would say the density is either 2.7 or 2.70 or 2.707 or something like that, and then test you to see if you get the right number of significant digits. I sort of just forgot to do that here.
So just
Whatever density you can find. So you should either have 1600 or 1610 or 1607, depending on the number of significant digits in your density. Because that limits, or actually no, you only have 3. The 3 is the most you can have because your length and your radius are only 3 significant digits. So it would either be 1600 or 1610. That's the total number of significant digits. It's either 2 or 3. Okay? I think we have time for one more quick one before we head out. So who's got a suggestion for the last one before we?
I have a question before
Yeah.
we move on. So to get, because it went from 16.06.998. So
Mhm.
anytime if it's 3 significant numbers, we go backwards to 1600.
We have to report this number in 2 or 3 significant digits, depending on however many we were given. If we have 3, we immediately eliminate those, and we start over here with 1, 2, 3. Those would be the 3 significant digits. And so since this last one is a 0 and there's a 6 next to it, we would round up to 1610. If we only have 2 significant digits, we would start with our 1. That would be significant. Our 6 would be significant, and nothing else after that would be. We just have zeros after that. And so I look to the right of this 6. I see a 0, so it stays the same, and I just give 1600. Okay? Yeah. So yes, you just go all the way to the left, and that's where you start with your significant digits. Just go all the way to the left. And your first non-zero number to the left is your first significant number. If, on the other hand, let me erase all this crap. If I had, trouble with the pen. If I had 0.00685, my first non-zero, this is a decimal, my first non-zero number to the left. So not this, not this, not this, that one is my first significant digit. So if I had to report this with 2 significant digits, this stays, these 2 stay, but just as placeholders. Just as placeholders to tell me how big or how small the number is. And I would go, this is significant, this is significant, that isn't. So I would change, this stays 6, this gets rounded up to 9. So that would be the answer with 2 significant digits, okay? All right, so anyone want to pick out the last one we do?
Number 6.
6. Is it this? Which one is it? I should have.
What length of copper wire with diameter?
Oh, we just basically did
Okay, sorry.
the copper. Yeah, we basically did that same one. You just need the density of copper. So look up the density of copper in grams. Usually they're given in grams per cubic centimeters. And then just use the same formula. Volume equals pi r squared length. There's your diameter. And figure out what the density of copper is. And so that'll give you a mass. And you just basically go backwards and you convert mass to volume. And once you've got your volume and your diameter, then you just work out the length, okay? Basically, it's exactly the same question as the previous one we just did, except you start with the mass and you work out the volume rather than the other way around.
Can we do number 7?
This one?
Yeah.
Is this 7? The
Yeah.
Yeah.
Okay. That's pretty similar to to that one too, but yeah, we can do this one. Sure. So basically this is yet another volume and mass. So what we're going to need, let's see what the information we're given. So we are given a ball bearing has a diameter of 3 millimeters. And we have a mass, we have 10.0 kilograms of iron ore. And it is 47% iron. So the first thing, what do we want to do? We want to work out how much mass of iron we have, right? I mean, that's the very first thing we need to determine. So if I have 10 kilograms of ore, and I want to convert that to kilograms of iron, how am I going to do that?
Multiply by million. Sorry.
So of the ore, how much of it is iron? So I've got 10 kilograms of rock, but only some of it is iron. How much of it?
47%.
47%, exactly. So what do I multiply my 10 kilograms of ore by to get kilograms of iron?
47%.
So what number do I use? So if I multiply by 47%, what number is that?
So
47% means 47 out of 100, right? That's what percent means. It's French for personne per 100. So what do I multiply this number by? I multiply this number by something. 47.0 out of 100. That's what I multiply it by. Get my kilograms of iron. So how many kilograms of iron is that?
.47.
How many kilograms?
4.7.
4.7. No. 4.7.
0.47.
Not 0.47, nope. 7 is right, but it's not accurate. That's the number, but it's not precise enough because we have 3 significant digits here and we have 3 significant digits here. So what should my answer be in?
Significant digits.
Should be 3, right? So my answer should be 4.70 kilograms. And that'll be important later because remember, carry as many significant digits as you can. I mean, you could have 4.7, you could have as many zeros on that as you want, and it's fine because you don't worry about it till you get to the final answer. Then you start rounding. Don't round too early. So 4.70 is the actual number. So I want to convert kilograms to area, volume, because the ball bearings have a volume. This is how I calculate the volume. So I want to convert mass to volume. So what am I going to need to do that?
Density.
Yep, same as before. Same as before. We're going to need the density. So now we're going to need the density of iron. So what's the density of iron? That one I can't remember off the top of my head. Some reason aluminum stuck in there, but iron I can't remember.
7.874.
Remember, that's the number. It's,
Grams over cubit.
there you go. 7.874 grams over probably cubic centimeters, right? Is it cubic centimeters?
Yeah, it's cubic centimeters.
Yeah, okay. Grams over cubic centimeters. So I have a mass, I have a density. One problem, I got kilograms here, but I got grams here. So how am I going to get around that? I want to convert this to grams. So I'm going to multiply that by something to give me grams. So I want kilograms on the bottom. I want grams on the top. So my kilograms will cancel. So what do I put in here?
1 gram over 1,000 kilogram.
Nope. See, that's why I like doing the multiplication. How many grams? There's not 1,000 kilograms in a gram because kilograms are bigger, right? Kilogram is bigger than a gram. So there has to be lots of grams in 1 kilogram.
1,000 gram over 1 kilogram.
There you go. Yes, there's 1,000 grams in a kilogram. Yes. So kilo is 1,000, not 1,000th. A 1,000th would be a millimeter. Right? That'd be a milligram. So kilograms are bigger. So whatever's bigger, that has a 1. Whatever's smaller, that will have a larger number associated with it. So it's by 4.70. And the other thing is to remember that this is precise. There's exactly 1,000 grams in a kilogram. So we don't worry about significant digits there. So there's 1,000 kilograms in 1.00000 kilogram. That's a precise number. That's a count. So how many grams of iron are we dealing with?
4,700 grams.
Yeah, 4,700 grams. Now, got a lot of stuff here. Let's erase some of it. What I want to do is I want to convert my 4,700 grams to a volume. So here's my mass, 4,700 grams. And I want to multiply that by something to give me cubic centimeters. I use my density. So I want to have grams on the bottom and cubic centimeters on the top. So what do I put for, here's my conversion. What do I put in my conversion to get my units? I want centimeters cubed on top. I want grams on the bottom. What numbers do I put in there?
One over 10, 10 over 10 cube over one. Or
Is there 10 grams in a cubic centimeter? That's not accurate. How many grams are there in a cubic centimeter of iron? Remember, this is iron we're talking about.
7.8.
There you go. Yeah, that's where our density, we're doing our density conversion because we're converting mass to volume. And the relationship between mass and volume is density. So there's our 1 cubic centimeter. And my 7.874. So how many cubic centimeters does that give me?
Five nine 6.90.
Yeah, 5.5.90, and then you could just keep going, like 0.1. It doesn't matter. Use as many significant digits as you want here, because we're not done. So just carry as many as you like. It's not important, but carry at least 4, right? Because we have 4 here, and so you might as well carry at least that many. So that's their number of cubic centimeters. Problem is, our diameter is given in millimeters. So there's one of two things we can do here. We can convert that number to centimeters and do our calculation, or we can convert cubic centimeters to cubic millimeters. Either way. I think it might be easier just to change the diameter to centimeters and then do our calculation there. Do people agree, disagree? Either way you want to do it. Basically what it means is we have to have this unit match this unit. And there's 2 different ways we can go about it. If we change the diameter to centimeters, how many centimeters would that be?
Cubic centimeter.
If we change 3 millimeters to centimeters, how many centimeters would that be? So we want centimeters on the bottom. Oh, sorry, we want centimeters on the top. Duh. Centimeters on the top, millimeters on the bottom. So for every 1 centimeter, how many millimeters are there?
10.
10. So how many centimeters would we have? What would our diameter be?
30.
Nope. Remember, it's 3 times 1 over 10.
0.3.
There you go. 0.300 centimeters. So let's just use that as our diameter. And then we'll use that to calculate our volume, okay?
However, I have a question. If I just say 0.3, that's it. It's not correct?
No.
Okay.
But it doesn't matter for your calculation because multiplying by 0.3 and multiplying by 0.300 is the same thing. It doesn't matter right now. The only time it matters is in your final answer. So if you just want to have 0.3, that's completely fine. That's not going to affect your answer. What I would do is I just carry over as many significant digits as I need. Like for instance here, just might as well have all those significant, you got them all, you might as well use them. But when you're multiplying or dividing by 0.3 or 0.3000, you're going to get the same answer. So that doesn't matter. What does matter is at the end, you have to report the right number of significant digits. That's all. So that doesn't really matter. So let's figure out what our volume is. So our volume is 4 divided by 3 times pi times our radius, and this is our radius here. So 0.3, and here I can put just 0.3 and it's fine. Centimeters. And then we cube that, right? So what's my volume? So 4 divided by 3 times pi times 0.3 times 0.3 times 0.3. What do people get for volume?
Zero point 1130.
Yep. 0.113. I'll just keep going, right? We just
Cubic centimeters.
actually no. I mean, I would just include all the digits. 113097. See 1131 because the actual number is 113097. So might as well you can just round that to 1. That's probably fine. Cubic centimeters. So remember, we have to have a unit. So now we're almost done. It's a long question. It's a good one to end on because this is a long one. So what unit are we looking for? That's actually kind of tricky for this one. What's the unit we're looking for?
Is it grams?
No, it isn't actually. 1131. Because we've got this is our total volume of iron. This is the volume of one ball bearing. What's the question actually asking?
How many iron ball bearings?
Yeah, so the answer we're looking for is number of ball bearings. So actually, this time our answer will be unitless. It'll actually be a count. So for once, you will have a unitless answer. That'll be correct because it's just a count. Okay. So how are we going to go from cubic centimeters to number of ball bearings? So I'm going to take. I've got my total volume here, and I need to convert that. I need to multiply that by something to give me number of bearings. So what am I going to multiply this by? So basically on the top, I want bearings, and on the bottom, I want cubic centimeters. What do I put there? So one bearing is how many cubic centimeters?
Is it 10 cube?
My what?
Is it 10 cube?
Why 10? Where does 10 come from?
Oh, I thought 10 as in centimeters and then cubing.
What's the volume of one ball bearing?
0.1131.
Right. That's what we calculated here. So we use the diameter of 0.3 centimeters to figure out what the volume of one ball bearing is. So one bearing has a volume of 0.1131 centimeters cubed. So how many ball bearings is that? So the centimeters cancel out. I got centimeters in the denominator. I got cubic centimeters in the numerator. So I don't have any units anymore. It's gone. But what I do have is bearings. That's left over. So that's actually my unit, is number of bearings. So how many bearings do I have?
5,277.
5,277.
Point.
0.64. That seem about right?
Mm-hmm.
Bearings. So I've got my unit, which is just number. But now I worry about significant digits. So I can carry all the significant digits I want to this point, because this is the final answer. So it has to have the right number of significant digits. So how many significant digits should I have?
3.
3, that's right, because there's 3 here, there's 3 here, and there's 3 there. So each one of the 3 numbers I was given to start this whole long process had 3 significant digits in it. So my final answer should have 3 significant digits in it too.
The 5280.
Yes, exactly. So my final answer should be 5,280. So here's my first significant digit, here's my second one, here's my third one, and then I use the one to the right of it to figure out what to round it up or leave it. And it's bigger, it's 5 or bigger, and so I round it up. My final answer is 5,280 bearings.
No, I have 4-digit number, the final answer, not the 3. Or 0 doesn't count.
0. This
Like 5, 2,
this
8.
0 is not significant.
Okay.
I don't put a decimal. If a decimal past it, then that means that it isn't 5,281 and it's not 5,279. We can't be that precise because we only have 3 significant digits. So all I can say is that it's not 5,270 and it's not 5,290. It's somewhere in between. So I have to say it's whatever's the closest 10 to this number. And the closest 10 to that number is 5,280. That's what the 3 significant digits really means. It means we can only get significant to the tens. If 2 significant digits, we can only count in hundreds. And if there's only 1 significant digit, we can only count to thousands. That's what it really breaks down to. And if I put a decimal at the end, if it's 5,280 with a decimal point, that means I can count right down to the ones, but we can't here. Okay? That is our time. So any other quick questions before we wrap up?
I actually have a question. Like, how do you get access to like this slideshow with all the questions?
The slideshow should be on Canvas. You haven't been able to find it? It's right on the home.
Yeah, on the homepage.
It's not there?
Let me
It's
check.
a file.
It should be published. It should be there.
On files?
Yeah, it should. Well, yeah, it definitely should be one of the files, but it should be under its own heading. Here, actually,
It's in file. I found it from files.
let's go to the screen. All right, I'll quit here. For some reason I can't. All right, here we go. So let's go dashboard. Here's our section. And just scroll down. Oh, I should have student views. See what you guys can see. Student views. Right. Lecture slides right here.
Chapter 1. Okay.
Just click on that and it should give you, yeah, you can either download it, or if you don't want to download it, you can just watch it. You can just scroll from here. Okay?
And so we have to have all these problems done by next week?
The ones in the recitation, yes.
Okay.
Or they don't
So
have
it's
to
just
be right. Just take a stab at them.
all right.
I have a
I just want you to try them.
Is it at like the bottom or
Just the bottom. What do you mean?
like which like towards like which slides? Because since there's 80 slides.
Oh, those are the lecture slides. That's not the recitation. The rest is, well, let me go back. That would be, let's go home. Oops. Damn it.
Yeah.
Oh, found it. Recitation worksheets.
Yep. That's what we're looking for.
Cool. All right.
I have a quick
Got
question.
Yes.
For the recitation, are you gonna eventually post like the answers? Because
Yes.
what if? Okay.
Yes,
Okay.
yes. So you can actually you can use them to study. Yeah, definitely.
When will you post the correct answers?
Probably
Will it
like
be after the due date?
Probably like 3 weeks after the due date.
Okay. Okay. Sounds good. Thank you.
Yeah, because obviously, yeah, you don't want, people just to wait till the key is published. You know what I mean? So, but they'll be there before the exam.
I have a question about the schedule for our
Okay.
recitations.
Mm-hmm.
Are we normally going to end at 2 p.m. like now?
Yeah,
Because
normally we can go longer if you like, but I mean, usually 2 hours is plenty. I mean, I get tired of hearing me in 2 hours. I can't imagine you guys want to take it much longer than that. But yeah, but if you have questions, yeah, we can certainly hang for longer.
okay, I was just making sure because on
You can hear
Canvas
my
you have
voice starting to
3
go.
listed.
Yeah, I think it's listed for 3, but I mean, I don't think anyone wants to do that. Well, maybe you do, but that's a long time.
I have a question. Will you be hosting office hours this week?
Oh, yeah, man, yeah. Supposed to be Tuesdays and Thursdays at 11, but yeah, I totally spaced that out today. Yeah, yeah, so it'll be Thursdays at 11. Totally.
So do we have a
Thanks for
lecture at
reminding
4
me.
today?
Yes. 4:50.
4 to 5?
4:15 to 5:45.
Okay.
Yeah.
Will this recording be posted on YouTube as well
Mm-hmm. Yep.
by this weekend?
Yeah, yeah, it should be. Yeah, I'll have time on Saturday to do it.
Okay.
But yeah, I have a lot of, man, there'll be a lot of editing to do. Mostly just chops off the beginning and the end.
In the exam lecture, it will be include the lecture slide and the recitation problems.
Mm-hmm. Yep. Mm-hmm. That's correct. And so I would review those. I would also review the questions in the textbook, because they give answers, I think, that every other question. So you can check your answers.
Is that a question in recitation? I can find this question from the book, or they are different? You are creating different.
They're different.
Oh, okay.
Different questions. Usually there might be one we've poached from the book, but usually they're different.
So the lecture later today, that's mandatory, right?
No, lectures are not.
Oh. Okay.
Yeah. Yeah, because a lot of people have a really busy schedule, and so Yeah, the
So yeah.
college wanted to have like more flexibility for online learning.
So the labs and the recitations are the only ones that are mandatory.
Yeah, and really the labs. I mean,
Okay.
if you can do the recitations without coming, doesn't bother me too much. When it was in person, I found that it was really good to get people to physically come to them, because then they'd hang out with their fellow students, and they'd help each other, and they'd form study groups and all that kind of stuff. When everyone's at the end of a computer, yeah, you can't. It's kind of tough to get a study group going, but I mean, you should try.
Mhm. So when the videos are posted on YouTube, where could we like find them?
Well,
Would there be like a link?
there's a link to the YouTube page.
Okay.
Right here, YouTube page.
All right, cool. Got it.
And there'll be separate links on the home page as well. So I think on the home page I've put a place for, where are they? Oh, it doesn't show. All right, maybe I just haven't published that. Yeah, there'll be separate links, probably like here under chapter 1. I'll have a link to the different lectures. I perhaps didn't publish that yet. There's nothing there anyway, because I haven't edited and posted the lectures yet.
Are we
So
doing
do
like chapter 1 today, or
Yeah, we're going to keep going with chapter 1. Yeah. Yeah, there's still plenty to get through.
so do we have to finish a pre-lab by tomorrow's lab?
I don't think there's a pre-lab in it.
Okay.
I can't
Okay.
remember. I don't think there is, but no.
All right.
Yeah.
we'll
All
just
right.
do the online lab, and if there's no pre-lab in the online lab, then we don't have to do it.
No. If it says, it should say very specifically, like, these are the questions and they, must be submitted, but I haven't. If I don't set up a place in Canvas to submit them, then you don't have to do it.
Professor, I have a question not related to this class. On fall semester, the way we will have like chemistry and other science class, gonna be the same way, or it's gonna
I
be
think so. I think right now the plan is yes, to do it remotely. But it all depends on what the county health officer guidelines are. So if the county says that it's okay to do in person, then, I mean, we may do that. But right now, the physical distancing is still in place, so we can't. So it really, we'll have to wait and see what the guidelines are. But right now, we're planning on doing it remotely. That's the plan.
I have a question for your office hour. Would we have to email you to see if you're coming to that time?
No, I'll just be there, and you can just show up. I just totally spaced it this morning because I've been, to be honest, this sort of lockdown has been going on so long. I just forget what day it is. I mean, you must have the same problem, right? Like every day seems the same. So I completely forgot what day it was. So I apologize. But yeah, what I'll do is I just turn on the Zoom and you can just pop in if you want.
So it'll be 10:30 to 11:30, right?
Yes. Yep. Tuesdays and Thursdays. And if you have if there's some special emergency you're having, or desperately need something, yeah, just drop me an email. We can set up a thing. You can either call me or we can set up a Zoom. Okay. All right. I have to go walk my doggies before class. So I'll see some, if not most, if not all, in 4:15. Okay.
Okay.
Thank you.
All right. Thank you, guys.
Thank you.
We'll talk to you soon.
Thank you.
All right. Bye-bye.